Alright, so the next thing I want to show you is how to solve equations with fractions. So there is one technique that I use a lot, and it helps with making it a little easier in working with fractions. It goes on the premise that if I multiply every term in an equation by the same number, then the equation still is true. So for example, I have something like this: 3 plus 2 equals 5. If I multiply every single term in both sides and every single term by 2, for example, the equation would still be true. So if I multiply 3 by 2, I get 6. Multiply 2 by 2, I get 4. And then multiply 5 by 2, I get 10. So I multiplied each one here by 2, and I got 6 plus 4 equals 10, which is true. If I do this again, like let's say I multiply everything by 10 on these. So 3 times 10 is 30, plus 2 times 10 is 20, equals 5 times 10 is 50. So again here, 30 plus 20 is 50. So that's what I'm going to do when I have fractions. I'm going to multiply every term by the same number so that I'm going to kind of get rid of the fraction. So let's see how we're going to do this. I'm going to multiply each term by the common denominator. Okay, we'll start with the first one here, 3/8 g minus 2/5 equals 4/5. Okay, so here we are, fractions. Now I can do what we've always done, which is add 2/5 to both sides, and then actually let me go ahead and do that. I'll to resolve this, so I'll add 2/5 because I want to isolate the variable. I have 3/8. This becomes 0. 3/8 g equals, and this is going to be 4/5 plus 2/5 is going to be 6/5. Then, in order to resolve this, I multiply both sides by the reciprocal of this number, which is 8/3. Okay, and then this would be 3 times 8 is 24 over 24. 3 times 8, 8 times 3, 24. G equals, this is going to be 48 over 15. Okay, and then this is basically 1. 1 times g is just g, so g equals 48 over 15. And if I reduce both of them by dividing them by 3, I get g equals 16 over 5. Okay, and that's a good answer. So if I take 16 over 5 and put it back in here, I would be able to make this equation, it would be true. Let's try it a different way though. Here's another way. I'm not sure if it's going to be easier or harder, but it's just another way. So the other thing I can do here is multiply each term by the same number and help get rid of all these fractions. So I would multiply each term by the common denominator of 8 and 5, which is, I'm going to use 40. 40 is the common denominator between 8 and 5. All right, so I'm going to go ahead and write that in a different color so that you can see how this looks. So I'm going to do 40 times 3/8 g. Oops. I'll put 40 here. Minus 40 equals 40. Okay, that's, and I'm going to bring down 3/8 g. 3/8 g minus, oops, 40 times 2/5. And then 40 times 4/5. Okay, now you're probably looking at this and going, how is this going to help? But let's see how we resolve this. So this is really 40 over 1. I'm going to be multiplying these two across that way. Same with all these, it's 40 over 1. I'm multiplying just two fractions. But when I have something like this, what I can do is reduce the 8 and the 40 by cross-canceling here. I know that 8 goes into 45 times, so I'm going to say this 8 goes into 8 once, and 8 goes into 45 times. Okay, so I just reduced 40 and 8. I've divided both sides, the top and the bottom, by 8. And now I've got a 5 here, 5 over 1 times 3 over 1. So 5 times 3 is going to be 15g now. 5 times 3 is 15 times g is just g. 1 over 1 times 1 is just 1. So I've taken away the fraction here, minus, and here I'm going to do the same thing. I'm going to divide both sides, cross-canceling kind of by 5. So 5 goes into 5 once, 5 goes into 48 times. And now I've got, again, 1 times 1 is 1, but 8 times 2 is 16, equals. Here I'm going to do the same thing, divide both by 5. 8 times 4 is 32. Okay, so I've taken this fraction, this problem, multiplied each term by 40, and now I've got this. And I know a lot of you can work with this. So I'm going to add 16 to both sides. And I'm going to get 15g equals 48. And I divide both sides by 15. And remember, g equals 48 over 15, which is what I got the first time. And if I divide both sides divide the top and bottom by 3, I would get 16 over 5, which is the same answer I got before. All right, I'll do another one here. Let's go with 2/5 h plus 3/4 equals 7/10. Okay, so that's 2/5 h plus 3/4 equals 7/10. Okay, again, a lot of fractions here. What I could do is subtract both sides by 3/4, and then I would have to find a common denominator here and do a bunch of stuff. Or what I could do is find the common denominator between all three of these and multiply each term by that number and get rid of the fraction. So that's what I'd rather do. Now, finding the common denominator for all these things is going to be a little tricky. I could multiply them all. I could say 5 times 4 is 20 times 10 is 200. That's definitely one of them. But there is a smaller number, and that's 20. 5 goes into 20 evenly, 4 goes into 20 evenly, and so does 10 go into 20 evenly. So that's what I'll do. And I'll go ahead and show that here. I'm going to multiply each term by 20. So 20 I'll do plus 20 equals, and I'll put 20 here. And now I'll bring down, I'll just show 2/5 h, so 20 times 2/5 h, and this is times 3/4, and this is times 7/10. Okay, so here I'm going to reduce each fraction. Now I can do that. So again, this is 20 over 1, 20 over 1, 20 over 1. So 5 goes into, 5 divided by 5 is 1, and then 20 divided by 5 is 4. Okay, now I do 4 times 2, which is 8, and we have an h, so we keep that, plus, and this one I'm going to divide 4 here, 25 times, 4 divided by 4 is 1, 20 divided by 4 is 5, so 5 times 3 is 15, and again the denominator is 1, equals, and on this one 10 goes into 10 once, 20 goes into 22 times. 2 times 7 is 14. All right, so basically I know I'm going to reduce this down, and I know the denominator is going to be a 1 here eventually, and then I take whatever's left, multiply it by the numerator here and a variable. I do the same thing here, I reduce it, whatever I have left over I multiply by this to get this, and then I do the same thing on this side. Remember, each term has to be multiplied by the same number. So now we can all, a lot of us can do this now. I have 8h plus 15 equals 14. I subtract 15 from both sides, and I get 8h equals -1. Divide both sides by 8, and I get h equals -1/8. And that's my answer. Okay, and I'll do one more to help you guys understand this. I know it may look a little hard, but it's once you can start doing it, it makes life a lot easier when dealing with fractions. So the last one I'll do here is okay, I'll do 4/9 p, 4/9 p minus 4 equals -2/3. Okay, 4/9 p minus 4 equals -2/3. All right, and what I do here, again, I've got fractions. I could add 4 to both sides, convert this to thirds, and then add that, and then multiply by the reciprocal. Or again, I'm going to try to find the common denominator here. So 9, and really this is a denominator of 1 and 3, so it's going to be 27 is my common denominator. So I'll take, here I'll just write 4/9. 4/9 p minus, I'll make some room here. Okay, so I'm going to be using 27. That's my common denominator. Put the 4. I'll rewrite that. Okay. So 27, and this is 4. And then we make this because we're multiplying. All right. So here I'm going to go ahead and start reducing this. 9 goes into 9 once. 9 goes into 27 3 times. 3 times 4 is 12 p minus, okay, and on here there is nothing to cancel, but I do need to multiply these two numbers to make the equation valid. So 27, a lot of people will skip this and just say minus 4 here, but that's totally incorrect. You have to multiply this by 4. So if I do 27 times 4, it's going to be 8, carry the 2, 8, 9, 10, 108. Minus 108 equals, and here I'm going to cancel out. 3 goes into 3 once, 3 goes into 27 9 times. 9 times negative 2 is negative 18. Then I add both sides. Let's see if you guys can see this. Just want to review here. 9 divided by 9 is 1. 27 3 times 4 is 12p. These two multiplied is going to be 108. 27 times 4 is 108. And then here at 3 goes into 3 once. Into 27 9 times. 9 times negative 2 is negative 18. All right, now I add 108 to both sides. Okay. This is going to be 12p equals, and I have a positive and a negative, so I'm going to subtract the smaller from the larger. So I get 90. And then divide both sides by 12. And I get p equals 90 over 12. And I divide both of these by 2. Let's see what we get. I get 45 over 6. And that's my answer. Okay, 45 over 6. And that's a value for p that would make the equation true. Okay, hope that helps.